Okay, guys, this is going to be a quick set of notes on energy bar graphs. So let's make that the title. For you guys, it'll be the topic. Um, okay, I guess I'm just going to write bar graphs. Bar graphs it is. Um, okay, and so our essential question is going to be, how can I use bar graphs to represent energy changes? How can I use bar graphs to represent energy changes? And so what I want to do is I'm going to give you guys a set of steps that you can follow when you're making these bar graphs. So I'm going to go quickly through the steps and then we'll do some examples. So step one is going to be identify types of energy present. Do this. I'm going to make my cursor just a little smaller. Okay, so that's step one. Identify the types of energy that are present. Step two is going to be identify the energy at point A and not but, put it on the graph. And I'm going to put a little note here also. Don't forget total. Okay? Don't forget the total. You guys probably can't read that. Don't forget the total. Okay. Okay, step three is going to be identify the energy at point B. And put it on the graph. Okay, and again, we're going to include the total, but the total might change. So the total does not have to be the same between point A and point B. Sometimes energy gets transferred into or out of the system. Okay, 4. Now we're going to ask ourselves some questions. Now, on the assignment that you guys do today, you will be asked these questions. So we're going to put them on here, okay? So did total energy change? Oops. If it did, where did it go? Okay, so we're going to say did total energy increase or decrease? If it did increase or decrease, we have to figure out where it went. So if it decreased, then it left the system, and we want to know where it went to. If it increased, then it entered the system, and we kind of want to know like where it came from. Okay, so let's do, that's enough writing, let's do some examples. So example one, and here I'll do this, let's go. Okay, so example one. Now I'm going to make a drawing here. So I'm going to say that we have a ramp, and on our ramp we have a car. Man, that's a good car. Okay, and so the car starts at the top of the ramp, and then it travels down to the bottom of the ramp. Okay, so this is going to be point A, this is going to be point B. Okay, now I'm also going to define our system. So we'll do this problem for this system, and we'll do it for a different definition of the system. So if my system includes the car and the earth, and I'm going to ignore friction for this one. Okay, so we'll do like no friction. So if my system includes the car and the earth, I'm going to follow my steps. Step 1, identify types of energy present. Well, when I look at this, if I've got the car and the earth, I know I'm going to have gravitational potential, and then it's going to start moving, so the movement's going to be kinetic. So when I go to make my graphs, I'm going to have a graph for A, and I'm going to have a graph for B. And those graphs here, they end up looking kind of like this. So I got like dot, 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 dot. Okay. So you guys can draw this out on your sheet. Obviously, when I give you the assignment, this will already be drawn in. Now, I have to identify the types of energy. So I told you there's going to be gravitational potential, there's going to be kinetic, and then we're also going to have total. So I'm going to have those same types of energy for both. For both of my graphs. Okay, so next step is to identify the energy at point A. All right, so if we look at A, it's not moving yet, but it is. It has a height, so it's going. It has the potential to fall because it's up off the ground. So I'm going to say that all of my energy is gravitational potential energy. Now remember, and I'm not going to have any kinetic because there's no movement yet. Now remember that I also have to include my total bar. So for the total, I just add up all the potential and all the kinetic. And since it's just gravitational potential, my total is going to be the same height as my gravitational potential. Now B, when I look at the car, now the car has made it to the bottom. So the car is moving, but, zoom in on B, the car is moving and now it's down to the ground, okay? So it doesn't have any more height, it doesn't have any more potential to fall, so all of its energy got changed into kinetic energy. Oops, and let's change the color of that. Oh man, I messed stuff up. Put my red squiggles back. There we go. So let's make this purple. So kinetic energy is going to be purple now. Okay. And total is still going to be red. So all of that potential, okay, all that potential got changed into all kinetic. And so when we go ask ourselves these questions now, which by the way, I did step 3, and now I want to do step 4. Did the total energy change? Well, the total energy looks the same at the beginning as at the end. So what that means to me is that the system did not gain any energy or lose any energy. It stayed the same. So I don't need to worry about where the energy went. Okay, let's do example 2 now. And I'm going to use the same car setup. If you want to draw it again, you can. If you don't want to, you certainly don't have to. But now my system is going to be defined differently. So my system, instead of being the car and the earth, is going to be just the car. So I'm going to draw the same graphs, A, B, and I've got dot, 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 dot. I know I'm an amazing graph drawer. Okay, so, and I'm looking at gravitational potential, kinetic, and total. Gravitational potential, kinetic, and total. Okay, so I've got my graphs drawn, but I need to fill them in now. So I'm going to look and I'm going to say, okay, at point A, what kind of energy is there? And your first inclination is going to be to say, oh, well, there's gravitational potential. But look, in the system, there's no Earth. So if there's no Earth in the system, I can't have gravitational potential. Well, it's also not moving. So check it out. At point A, there is no energy. Okay, there's nothing there, so I'm just going to leave that completely blank. Now at point B, the car has some energy because now it's moving. Okay, still no gravitational potential, but now I've got some kinetic energy because it's moving. And I still have to do my total like that. Okay, so now we really have to look at what happened here because we went from no energy to lots of kinetic energy. So we got to think about where did that energy come from? And so the answer is that that energy, okay, and we'll write it like this. So there was energy transferred from Earth to the car. And that happened through gravity. Okay? And so then it wants to know what does the work. So we're going to say, whoops. We're going to say Earth did work. So the Earth lost some energy and gave some of its energy to the car. So we're going to see a bunch of examples like this. Go ahead and pick up the worksheet now. Oh, don't forget to answer the essential question. So go down to the bottom, write your summary, and answer your essential question. All right, nice job, guys.